Recording in progress.
Hey guys, today I'll be teaching you about deciles of ungrouped data. But before we start, again, this is Mr. D of DSS Review Center. Sa mga hindi pa nagsasubscribe, please subscribe for you to be updated with our next videos. Okay, so deciles of ungrouped data is again part of measures of position. So let's see. Measures of position divide the data into equal parts, and this is important to determine in which group a particular score belongs. So in our previous video, we discussed about quartiles, where data are divided into 4 equal parts. This time, I will be discussing with you about deciles, which divide the set of data or distribution into 10 equal parts. Okay, so for your learning target for today, I can determine the decile of ungrouped data. And to determine the quartile of ungrouped data, you may consider the procedure below. Number 1, again, write the data in ascending order. Use the formula. Instead of Q, we use DK, where K represents the first decile, second decile, and so on and so forth up to 10th decile, okay? And then solve this and simplify the result. Use the result to determine the score by counting the data in the distribution. As you notice, the procedure in solving for the quartiles and the deciles are almost the same, okay? But here or today, you will encounter some scenario that gives you different way of solving. Let's consider this problem. The data below is the ages of 15 aspiring candidates running for 2022 senatorial election. So these are the data, and your goal is to find the following: first decile, the 5th decile, and the 8th decile. Okay, so for you to solve this particular problem, again, this is the problem that you have to solve. And again, we have here the procedure so that you will be guided on how to solve this problem in a step-by-step process. Okay, let's start with number 1. So for number 1, we are looking for the first decile. Okay, and for you to do that, for us to do that, again, write the data in ascending order. So this particular data, 15. Okay, we arrange it in ascending order. So you double check, okay, 44, 45, 48, 50, 53, 57, 55, 57, 60, 65, 68, 70, 73, 75, 79, 83. Okay, when you are doing this on your own, make sure that the data are really arranged in ascending order. If you miss something, that might give you different results. Okay, so since it's true, it's correct, the data is already ascending order, then let's proceed to the next. Use the formula, okay, and to substitute for K, since we are looking for the first decile, again, replacing K is just 1. And then for N, we will substitute 15. Okay, so which is the total number of aspiring candidates. So we have here, substituting 1 and 15, we'll have now 15 plus 1 is 16, times 1 is 16, and then divided by 10 is 1.6. Okay, so this is the scenario. You get 1.6. Now, how are we going to use this result? There is no 1.6 in the data because this is just 1 or first, second, third, fourth. There is no 1.6 place. So in that case, we will not simply count. We have to use a particular formula to be able to find the first decile of the distribution, because definitely 1.6 is between the first and the second data. That means the first decile is between 44 and 45. But how do we get the exact value of the first decile? Okay, you may use this formula: lower score plus the decimal point times the higher score and the lower score. So how are we going to do that? Okay, so look, this is actually the lower score, 44, and then the decimal point is the 0.6, and then higher score is 45, and the lower score is 44. Okay, so in that case, we have 44 plus 0.6 times 1. Sorry, so you start with this. 45 minus 44 is 1. 1 times 0.6 is 0.6 plus 44, you get, okay, 44.6. Therefore, the first decile is 44.6. Okay? Let's proceed to the next, fifth decile. So again, it is important to arrange the data in ascending order. And then after that, we use the formula. We substitute 5 since we are looking for the fifth decile. So 5 and then 15 for n. So we have now 15 plus 1 is 16. Times 5 is 80. Divided by 10 is 8. So we are lucky. The answer here is exact. So it's the 8th score. So here, if we look for the 8th score, just count. First, second, third, fourth, fifth, sixth, seven, 8. And as you notice here, the 8th score is actually 60. Therefore, the fifth decile or D sub 5 is 60. Okay, so if we look at the number here, it's the 8th score. All right, so let's proceed to the last item, 8th decile. We are looking for the 8th decile. Again, using this procedure, arrange the data in ascending order. Replace K by, correct, by 8 since we are looking for the 8th decile. And then still n, 15 for n. So here, 15 plus 1 is 16 times 8 is 128. Divided by 10 is 12.8, another non-exact value. So in that case, we cannot simply count because 12.8 is between the 12th score and the 13th score. Okay, so which is between 73 and 75. So if we use the formula once again, lower score, so we are talking about 73. The decimals, okay, 0.8, yung sobra dun sa 12, ano? So yan, 0.8. And then here, higher score, 75, and lower score, 73. So be careful about the MDAS rule or PEMDAS rule, okay? Wherein the numbers inside the parentheses should be simplified first. That's why here we multiply first, we subtract first 75 and 73. 75 minus 73 is 2. 2 times 0.8 is 1.6. So you have 73 plus 1.6. That gives you 74.6. And that justifies that the 8th decile is between 73 and 75, but it is closer to 75 because it is actually 12.8. Okay, so I hope you get how to solve for the decile of ungrouped data. Okay, once again, this is Mr. D. And for you to be updated with our videos, do not forget to subscribe and hit the notification bell. So, see you in our next video where I'll be explaining with you how to get the percentiles of ungrouped data. Thank you and good day.